Dr. Anthony Raj. He has pursued his bachelor's, master's, and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to DTH channel, lecture 14 of Astronomy and Astrophysics. This lecture is about universe, which is everything in present in universe. Universe means everything. That's all I can say about universe. Stars, galaxies, planets, like everything comes under universe. I am going to present this lecture in the following order: introduction, universe, Big Bang theory of universe, various objects in the universe, and the summary of the discussion. Universe is a fascinating entity, contains everything, many mysterious objects present. In the universe, Earth is the only object which has life. You can't find life anywhere else in the universe. Earth is the only object, only place where we can find life. Astronomers, scientists are still searching for a life in places other than Earth. Then, have we seen the universe fully? No. 3/4 of the universe is still unrevealed. Though many research are going on about the extraterrestrial life, then space, planets, exoplanets, many things are going about these objects. Still 3/4 of the universe is unrevealed. This universe is made up of innumerable galaxies. So far, millions of galaxies are identified by the astronomers and scientists. Apart from these identified galaxies, many unrevealed galaxies are there. We do not know. In the known galaxies, we are living in the Milky Way galaxy. In Milky Way galaxy, we are living in a solar system which has only one bright star, our sun. Milky Way galaxy is made up of many number of stars, millions of stars. Like that, all galaxies are made up of many stars. This is universe. In this lecture, we are going to see the objects, prominent objects present in the universe. Many solar systems exist in each galaxy. So far, in Milky Way galaxy alone, thousands of solar systems are found out by the astronomers and researchers. Our solar system consists of 8 planets. Apart from the planets in our solar system, other objects are there: asteroids, comets, exoplanets, meteoroids. Like that, different objects are there in our solar system, in our galaxy. All these comprises the universe. Asteroids exist between the belt between Mars and Jupiter. Now, coming to the actual definition of universe. Universe is a collection of galaxies. Uncountable number of galaxies in different shapes constitute universe. In galaxy, there are spiral galaxy, then elliptical galaxy, irregular galaxy, Like that, classifications are done by astronomer. These galaxies are formed by innumerable stars. Like that, universe comprises different objects. Now let us come to the question of when this universe was formed. Which theory explains the formation of universe more relevantly? Big Bang theory explains the formation of universe more relevantly. The experimental support, practical support for the Big Bang theory is images obtained by Hubble Space Telescope. Observations with the Hubble Space Telescope and other observations showed that universe is expanding at an ever increasing rate, implying that someday in the very distant future, anyone looking at the night sky would see only our galaxy and its stars. But today we are seeing many galaxies and its stars in our night sky using telescope. But in near future or very distant future, we can't see all those galaxies. The reason is the galaxies are entities present in the universe are receding from each other. The billions of other galaxies will have receded beyond detection by these future observers. That's the thing about universe. Then which one makes these galaxies to recede away? A force. Which force is that? That is the dark energy force. That dark energy force is still, it's not found out still. So this dark energy black hole pushes the galaxies apart from each other. This new unknown component, which comprises approximately 68% of the matter energy content of the universe, will determine the ultimate fate of all entities present in the universe. The unknown component is dark energy. Determining the nature of dark energy lies at the intersection of cosmology, astrophysics and fundamental physics. Cosmology plays a very important role in explaining these unknown matter energy force, dark energy force. Scientists are examining, observing, exploring about the cosmic rays which is coming out from different objects of the universe. This is the picture which explains the formation of universe. So here you can see the Big Bang. This Big Bang explosion has happened some 13.8 billion years ago. Then some 13.5 billion years ago, cosmic dark ages, first stars would have been formed at the age of 13.5 billion years from now. So in the 13 billion years ago, that reionization era has happened. Then the modern galaxies which are all formed would have been some 4 billion years ago. So our solar system might have been formed some 4 billion years ago. This is the Hubble spectroscopically confirms farthest galaxy to date. A support for Hubble support for Big Bang theory. This Big Bang theory throws light on the formation of universe. Hubble said that universe stretched and expanded to get as big as it is now, and it is keep on stretching. Just 2 years later, after the proposition of Edwin Hubble noticed that other galaxies are moving away from us. The farthest galaxies were moving faster than ones closest to us. This means that universe was still expanding, just like Lemaitre thought. If things were moving apart, it means that long ago everything had been close together like a point object. So everything we can see in our universe today, like stars, planets, comets, asteroids, are all not there at the beginning. There was only one point object. That point object exploded so that we get all the objects like stars, planets, comets, asteroids. When the universe began, that is at the time of explosion, it was just hot, tiny particles mixed with light and energy. It was nothing like what we see now. As every expanded and took up more space, it cooled down. After expansion, it started to cool. During this cool down process, the tiny particles grouped together, they formed atoms. Then those atoms grouped together over lots of time, atoms came together to form stars and galaxies. This is how the objects which we see today might have been formed. The first stars created bigger atoms and groups of atoms called molecules. That led to more stars being born. We know stars undergo different stages in its life: protostar, main sequence star, red giant, white dwarf, like that. Different stages of lifestyle stars undergo. All those stages might have been created by this expansion of universe. At the same time, galaxies were crashing and grouping together as new stars were being born and dying. Then things like asteroids, comets, planets and black holes formed. In that way, our universe have formed some 13.8 billion years ago. This is how Big Bang theory proposes the formation of universe. This diagram explains the accelerated expansion of the universe. So a tiny object exploded in a Big Bang way. Then this is the cosmic microwave background relic. Then dark age. Then after dark age, the universe started expanding. All galaxies have formed. All these galaxies have stars. Then in this picture, you can see at 10 power minus 43 second after the explosion of the Big Bang, the cosmos goes through a super fast inflation, expanding from the size of an atom to that of tiny fraction of a second. Then after 10 power minus 22 second, the temperature will be 10 power 27 degrees Celsius. That time inflation has happened. Then after 10 power minus 6 second, after the explosion of the Big Bang, 10 power minus 6 second, rapidly cooling cosmos exist. Quarks, then all these protons and neutrons are produced. Then after 3 minutes of the explosion, 10 power the temperature becomes 10 power 6 degrees Celsius. Then temperature kept on reduced. Now the temperature of the universe is minus 270 degrees Celsius. At the time of explosion, the temperature is 10 power 27 degrees Celsius. Now it has become minus 270 degrees Celsius. See how dramatically the temperature of the universe has changed. Then the galaxies are receding away from each other. So in future years, we may not be seeing other galaxies in our night sky. We can see only our galaxy in the night sky. In 1936, Hubble debuted a way of classifying galaxies, grouping them into 4 main types: the galaxies, spiral galaxies, lenticular galaxies, elliptical galaxies and irregular galaxies, because galaxies are the building blocks of universe. These galaxies are built by stars. So galaxies itself classified as spiral galaxies, lenticular galaxies, elliptical galaxies and irregular galaxies by Hubble in the year 1936. More than 2/3 of all the observed galaxies are spiral galaxies. These spiral galaxies has a flat spinning disk with a central bulge surrounded by spiral arms. That spinning motion at speeds of hundreds of kilometers a second may cause matter in the disk to take on a distinctive spiral shape like a cosmic pinwheel. Our Milky Way galaxy, like other spiral galaxy, has a linear starry bar at its center. In galaxies, the disk of stars orbiting the bulge separates into arms that circle the galaxy. These spiral arms contain a wealth of gas and dust and younger stars that shine brightly before their quick demise. One theory of galaxies suggests that the galaxy arms could be the result of density waves traveling through the outer disk of the galaxies. Then collision between galaxies could cause such waves as the mass of the smaller galaxy could affect the structure of the larger galaxy as the two collided galaxies combine. So this is how galaxies are studied as the building block of the universe. Then spiral galaxies. These spiral galaxies are thought to evolve into elliptical galaxies as the spiral gets older. One of the largest known spiral galaxies is NGC 6872, which is 522,000 light years across from the tips of its outstretched spiral arm. That's about 5 times the size of the Milky Way galaxy in which we are living. So this is a photograph taken by Hubble Space Telescope showing thousands of galaxies which comprises the universe. In future years, distant future, not near future, we may not be seeing this many number of galaxies as the galaxies are receding away from each other according to the theory of Hubble. This is a deep space image featuring countless distant galaxies of all shapes and sizes. This is how our universe is made up of. The next constituent of our universe is stars. There are two basic categories of star clusters: globular cluster and open cluster. These globular clusters of stars are roughly spherical groupings of stars that range from 10,000 to several million stars packed into regions ranging from 10 to 30 light years across. So if you take each galaxy, you can see these star clusters large in numbers. These globular clusters are commonly consist of very old population 2 stars which are just a few hundred million years younger than the universe itself. Globular star clusters are few hundred million years younger than the universe itself. They are mostly yellow and red. Open clusters, on the other hand, are very different. Open clusters are so named due to the fact that individual component stars are easily resolved through a telescope. These open cluster stars such as Hyades and Pleiades. So this is the photograph of Hyades star clusters and Pleiades star cluster. These two clusters are open cluster star group, clearly distinguished by the naked. They are sometimes called galactic star clusters due to their location on the dusty spiral arms of the plane of the spiral star cluster. Then coming to the classification of stars. Harvard Spectral Classification of Stars classifies the stars into 7 categories: OBA, FG, KM. This O stars are violet color stars. More than temperature is more than 28,000 Kelvin. M category stars are red color stars, less than 3,500 Kelvin. So in between you can see BAF, GK. This B is blue star, A is also a blue star, F, G, K are blue white, white yellow, orange red stars. Like that, stars, building blocks of galaxies, are studied very deeply to understand the formation of universe. The next object, famous object in our galaxy is comets. As theorized by astronomer Gerard Cuvier in 1951, a disk-like belt of icy bodies exists beyond Neptune in our solar system, where a population of dark comets orbit the Sun in the region of Pluto. These icy objects, occasionally pushed by gravity into orbits, bringing them closer to the Sun, become the so-called short-period comets. These short-period comets taking less than 200 years to orbit the Sun. In many cases, these short-period comets' appearance is predictable because they have passed by before. Then another object in our universe is asteroids. Asteroids, sometimes called minor planets, are rocky leftover from the early formation of solar system about 4.6 billion years ago. The current known asteroid to humankind is 9,58,526. These asteroids plays a vital role in understanding the formation of universe, throw some light into the Big Bang theory, because by knowing the age of this asteroid we can predict what is the age of what distance this asteroid exists from our solar system, then what are the objects farther than this asteroid in our universe. All these things can be calculated and observed to understand the universe more clearly. Most of these asteroids can be found orbiting the Sun between Mars and Jupiter within the main asteroid belt. Then coming to the size of these asteroids, the largest of an asteroid is 530 kilometers in diameter to bodies that are less than 10 meters across. The total mass of all the asteroids combined is less than that of Earth's moon. Then shapes of these asteroids are mostly irregular, though a few are nearly spherical, and they are often pitted or cratered. These asteroids revolve around the Sun in elliptical orbits. More than 150 asteroids are known to have a small companion moon. Some of them have two moons even. There are also binary asteroids in which two rocky bodies of roughly equal size orbit each other, as well as triple asteroid systems are there in our universe. So asteroids throws some light in the formation of our universe. So the objects in the universe are galaxies, stars, comets, asteroids, then exoplanets. Exoplanets are planets beyond our solar system. We know in Milky Way galaxy alone 3,800 solar systems are there, 3,081 solar systems are there, and 4,158 confirmed exoplanets are there in Milky Way galaxy alone. Like this, all galaxies may have solar system and exoplanets. Those are not still revealed by the astronomers. People are searching for the exoplanet. The exoplanets are potential candidates for life. Astronomers think that because the place at which the exoplanet exists comes under habitable zone. Habitable zone in the sense it should not be too hot, too cold. Then a star should be there in that solar system. Like our solar system, Sun is the star. In other solar system, a star like our Sun should be there. It should not be too big. It should not produce high heat. It should not produce high light. All these conditions fit to the habitable zone. Then coming to the size of the exoplanet, if it is a habitable zone, it should be 1 or 2 times the size of the Earth. It should not be greater than the size of the Earth. Then it should have atmosphere. Then the atmosphere of that planet should have water, vapor, and other affordable gases. So habitable zone is another area of research for astronomers to find life in universe other than Earth. So in this habitable zone, any exoplanet exists, then that exoplanet, any exoplanet is identified, then that exoplanet will be researched further for the existence of life. So in this lecture, we have seen things about universe. We learnt that universe is collection of everything we know today. 3/4 of the universe is still unrevealed. 3/4 of the universe is still unrevealed. Innumerable galaxies constitute the universe. Galaxies are formed by stars. Stars are classified into 7 categories. Broad classification of stars are open cluster stars and globular cluster stars. Milky Way galaxy is the one in which we are living. All the galaxies are receding away from each other. In distant future, we can't see other galaxies in our sky. The galaxies are receding in such a speed. Then stars, comets, asteroids, exoplanets, like many objects are there in our universe. Comets are icy objects which present beyond the Neptune. Then asteroids are between the Mars and Jupiter. A space is there in our solar system between Mars and Jupiter, that these asteroids are revolving around the Sun. The most known asteroid to humankind is Bennu, which is researched more elaborately. Then size of these asteroids ranges from 530 km in diameter to 1 meter in diameter. Then exoplanets, a planet present in other solar system other than our solar system are called exoplanets. These exoplanets may have life. Scientists are searching for a life in these exoplanets if these exoplanets exist in the habitable zone. Habitable zone is a zone in a solar system, other solar system, where it should not be too hot or too cold. Then the size of the planet should be 1 or 2 times the size of the Earth. This is how exoplanets are researched. So these are the things we learned from this lecture. You can learn more things about this lecture by surfing these websites. It will give a clear picture about universe. Thank you.